So today is going to be a review day. We do have like three more slides of 2.4, but we've kind of touched on a lot of new types of math, and I want to spend today doing lots and lots of review. So I'm going to start because we kind of already discussed stoichiometry last or Monday. We did mole conversions, and now we're going to connect all the dots. So I passed out this um, worksheet for us to work on. I'm going to have us do that for the first 10, maybe 10, 15 minutes, depending on how long it takes. If you are online and you'd like to download this, this is available to you under our Unit 2 module. There are two worksheets we're going to hit on today. So that's where both are, and both keys are there too. So if we don't have time to go over every problem, you still have access to the key. And just a big reminder, I do like to think about these types of questions for future quizzes and future short answer portions of the exam. So if we ever don't finish a worksheet in class, it's still good practice for those quizzes and exams. Speaking of that, homework is going to be due this upcoming Wednesday at noon. So do your best to get all of the homework done before next week. I know that some of you have finals today. I understand those are priority over this class since we don't have the exam until next week. But once your finals are done, maybe take the weekend to get completely caught up, get all of your quizzes out of the way, get all of your homeworks out of the way. Anything that is necessary, of course, but allowing you to have the next week to focus on just types of exam questions. That's my advice. You don't have to take it, but that's what I'm going to push for. So get everything you can done now. But yeah, so I'm going to ask all of you to get this worksheet out and start working on it. Remember that these stoichiometry questions we hit on last class, they didn't actually say a lot in the question, but I wanted to break it down and go over like 3 different steps you want to hit on. So if I do ask you a stoichiometry question, there are 3 steps you want to do. First, they're not always going to be nice and give you a balanced reaction. And so if you look at the way that I wrote the question, you can create your own reaction and you have to balance it. They're not going to tell you if it's balanced or not, but you need to be able to balance it. That's step 1. Create a reaction and balance it. Step 2, because these are stoichiometry questions, you're going to have to get that mole triangle really honed in your head and create those relevant equivalents. If you want to write out all the equivalents, that's what I would do. So I asked, create the equivalents using the mole triangle, and most importantly, what 2 equivalents are relevant to this particular question. And then once you have that, you can do step 3, solve it using dimensional analysis. And then don't forget your stoichiometric coefficients. That's why balancing is so important. So questions 1 and 2 are very similar. I just kind of have you create a reaction, have you balance it, and then solve it. So spend the next 10 minutes going over it. If you have any questions, ask. But, take yourself through those steps. If I do ask a question that relates to stoichiometry, even if I don't explicitly ask for steps 1 through 3, you still have to be able to do steps 1 through 3 every single time. So the second worksheet I passed out is the same question as this, except it doesn't have you break it down. So this is a great kind of start for, okay, let's do these 3 steps. And then once you're comfortable with this process, you can move on to the next worksheet. So this one says the Haber process combines hydrogen gas and nitrogen gas. What is hydrogen gas? What does it look like? H2. What about nitrogen gas? N2. And it produces ammonia, which is? So ammonium ion is NH4 plus. Ammonia is NH3. Is this balanced? No. So the best way to do it is just to count everything on both sides. I have 2 and 2, and I have 1 and 3. So the first thing I need to do is put a 2 out front of my NH3. That'll get it to 2, but now I have 6. So then I move that 3 out front here. And I have, 6. So you have to first balance it. if you were to try to use stoichiometry with an unbalanced chemical equation, it's going to throw off everything and you'll get the wrong answer. So this is kind of building off of what we did in unit 1.7, and at least we should be comfortable with balancing reactions. So can you create the reaction and can you balance it? That's just a review of 1.7. For unit 2 for this exam, we have to build. So step 2 is create the equivalence using the mole triangle. So you need to be able to understand the mole triangle is all equivalent to each other. So if you have the mole triangle in front of you, or if you remember what the mole triangle looks like, or if you remember the slides, you can either use the triangle or you can just kind of create a line of what is equal to what. So 1 mole is going to be equal to everything on that mole triangle. That's equal to 6.02 times 10 to the 23rd representative particles. 1 mole is also equal to the molar mass of whatever compound. That's grams per mole. And it's also equal to 22.4 liters of gas. That's everything in the mole triangle. Just because the question says create equivalence doesn't mean that we're going to use every equivalent for this question. We have to be able to pick out which ones matter. So if I read the problem, it says how many moles of ammonia can be produced with 2.3 liters of hydrogen gas. So I'm going to go to my equivalence and I'm going to find the units that the question is talking about. It says liters, so I'm going to go find liters. It says mole, I'm going to find mole. So the only 2 things that matter for this problem is that 1 mole equals 22.4 liters. And if you have those 2 equivalents ready to go, you can always do a dimensional analysis setup. So if you're starting with given 2.3 liters of hydrogen gas, and it wants you to convert it into moles of ammonia. I want moles of ammonia on top, and I want my 22.4 liters of H2 on the bottom. Sorry, I did H2 on as a habit. But this is where stoichiometry comes into play. If you look at the balanced reaction, the coefficients have to be involved when we do the stoichiometry. It has to be. I can't just leave it as this. I have to say, okay, well, NH3 has a 2 out front. So I'll bring that 2 and I will put that in parentheses and put that 2 out front. If there was a 1 out front, I would not need to do any of this. I can just leave it as is. But with that 2, it's important. With the H2, I have a 3 out front. And so I have to put a 3. That's where the stoichiometry is coming from. It's the ratio of one thing to the other. So we were able to set up the dimensional analysis using those equivalents. And then using stoichiometry, we just have to add that extra step in. If you learn this in high school a different way, or if you probably take a different professor's class, they might add extra steps here. And you just have to determine which option is easiest for you. If doing it in one step is easiest for your mind, go for it. If you like it in a different way, so I'll say this is option 1, option 2. So if this option 2 just kind of breaks it up into all their units. And with option 2, you convert everything back into the mole. Just like what we did when we were doing SI units, where let's say I have 32 micrometers and I want to convert that to kilometers. We did that similarly where I gave you 2 options. You can convert everything back into the SI base unit and then convert, or you can go directly in if you're comfortable knowing that. This is the same concept as that. So this would be converting everything into its SI unit or mole. So you got to pick what option is best for you. So if I convert 2.3 liters into 1 mole of H2 divided by 22.4 liters of H2, that's converting into moles first. And then you have to use stoichiometry using that ratio. So that ratio could mean moles, 3 moles of H2 plus 1 mole of N2 produces 2 moles of NH3. And that's where I'm getting that from. So you have to have that ratio somewhere in here. And lastly, it's asking, oh, sorry, actually, that is what it's asking. It's asking for moles of NH3. So I don't need to do the additional step. But if you look between these two problems, the math is the same. You're going to get the same answer regardless of what option you pick. But the hard part is just like making sure you're comfortable with what option it is. Okay, option one, use the straight convert, what we learned in 2.3 mole conversions, and then put the stoichiometry out front. That's option one. Option two is convert everything into the mole, and then use stoichiometry to adjust the ratios and then keep going. What did you get when you typed this in your calculator? Check your math. So what I would do in my calculator is you can do 2.3 multiplied, but in parentheses, do 2 times whatever numbers in the parentheses divided by open parentheses 3 times number close parentheses. You want to make sure that you type it in correctly, because if you don't, you'll get the wrong answer. Thirty-four point 34. Let me double check my math, because I got 0.15 and I might be wrong. Ooh, second, oh.
I got 34.
So let me type that one in. So I have 2.3 times, and in the top, I'm going to do 2. That's 2 times 1 divided by 3 times 22.4. And I got 0.068.
I got that when I did the option 2.
Okay. So 2.
So I definitely typed 1 is wrong, but 2, I just did it 1 step at a time. I did the 2.3 divided by 22.4, and multiplied that answer by 2/3. I got 0.068.
Yeah. So even my key is going to be wrong. I put the wrong numbers in.
So we have the 3 in the denominator, because looking at the top, you need 3 hydrogen to make it balanced.
Yes. Yeah, that's where I got that. Remember also, if there are 2 sig figs here, you want to be consistent and have your answer be to 2 sig figs. So 0.068, and that would be mole of NH3. And show all work to get full credit if this is a short answer. You don't need to show 2 options. You just need to pick the option that works best for you. And make sure you got that same number as me, because if you did, we gotta fix the calculation. Maybe it's my calculator, but we need to be able to fix how we type things in now.
I got it.
Perfect, okay. Ready to move on? So this one says propane combined with oxygen gas produces carbon dioxide and water. What does that reaction look like? So before you can balance it, let's write it out. What is propane? C3H8, all right, plus oxygen gas, O2, and then CO2, right? Sorry, I said carbon dioxide plus water, so that's H2O. We have to balance it. You can't just leave it as is. We can't always assume everything has a 1 out front. So C, H, and O. 3, 1, 8, 2, 2, 3. So first things, I'm gonna put a 3 out front of CO2. That'll change that to a 3. That'll change this out to a 6 plus 7. All right, next I want to get those hydrogens. I always will save the pure element to the very end. So the next I'm going to focus on hydrogen. 4 out front of hydrogen. Now it'll give me 8. And my oxygen will be 6 plus 4, and that's 10. So all I have to do on the left-hand side is put a 5 out front of the O2. to get me 10, and it is balanced. Step 2 is the same thing as what we did on the last page. You can either write out every equivalent if you prefer that, or focus on the equivalents from the triangle that matter to this problem. Because this problem is saying 300 or 532 grams of propane, how many liters of carbon dioxide? So we're focusing on grams and liters. So I could go to the triangle and say, okay, well, I just need 22.4 and the molar mass. I just need those two. I don't need to write it all out. If that confuses you, don't write it all out. But if you know you need to write it all out, this is the way I would do it. Is you just start off by taking that triangle, 1 mole equals 6.02 times 10 to the 23rd representative particles equals molar mass equals 22.4 liters. The order does not matter. It really doesn't matter. And then you can say, okay, well, I have grams in the problem and I have liters in the problem. So the only things that I need are these two, molar mass. And if I go through it, it's grams of propane. So molar mass of C3H8 equals 22.4 liters of carbon dioxide. Like, you just need to create an equivalence, because in order for you to do the dimensional analysis, you have to have that straight equivalent. So you can't start the next step until you have the two you want to focus on. But once you have those two, setting up the dimensional analysis is not so bad. First, what is the molecular weight of C3H8? So that's just taking 3 carbons plus 8 hydrogens. You will have a periodic table of elements in front of you. So if I don't provide that for you, which I will not, you will have to do that quick math. There's an error here, sorry, 3. So you'll have to be able to do that. So I'm not going to give you the molar mass. You have to figure it out using the periodic table. Next, start with what you're given, 532 grams of C3H8. Okay. You want to have what you want on top, and that would be liters of CO2. What you're given is on the bottom. In this case, is the molecular mass, 4.094 grams of C3H8. But you cannot leave it like that, because if I look at the balanced reaction up here, all of these numbers are not 1. If all of these numbers were 1, I could leave this as is. I could, and just put a 1 out front. But they're not. So I need to find the number in front of CO2. Actually, I forgot. This is 22.4. I need to put that number out front. And I should probably make it a habit to do the same thing, even if it is a 1. And that's option 1. Option 2 would be converting this into moles using molecular weight, then using the stoichiometric ratio, and then convert to liters. I'll write that down here. To kind of go back into your standard unit of mole. Moles are our happy little base unit. So that's going to be mole. Oh, that's not. These equations are the same. The math is the same. It's just how you like to set it up. If you feel like you're more likely to make a mistake when you're breaking it into 4 separate steps, then do it like this. Use the mole triangle to convert in what you're going for, and all you have to do is find your balanced reaction and bring the number and put that number out front. So it's the same thing we did in mole conversion, but we're literally just adding the number out front. And it'll get you the same number. I got an 811. What did y'all get? Perfect. Now the question is in 366. So just make sure your answer is in 366. I think I got an 810.6 or something like that, but I rounded it to 811. We're going to continue doing these types of problems. We have, I think, 2 or 3 more examples on those slides. Sorry, I have 2 more examples on the slides that are literally going to break it up into these 3 steps. So we're going to keep doing these over and over and over again, and then I'm going to let you do it on your own for a bit. And then I do have, I printed out the exams, and so I think with the downtime, we'll do a little bit of review on those exams for the next half. But yeah, I want to finish the 2.4 slides. If you if you missed the rest of the slides from last class, they are going to be in Wednesday's recording. But I paused it so we can work on the last 2 together. Okay. So this is essentially the same type of problem, but they were nice enough to give us the balanced reaction. So all we have to do here is kind of figure out what equivalents are important. So read the question thoroughly. I recommend reading a couple times until you really are sure of what it's asking for. Toluene and nitric acid are used in the production of TNT, trinitric toluene, an explosive. What mass in grams of TNT can be prepared from 829 grams of toluene? So this one is, we're looking for grams, and they give us grams. We can still use the unit triangle regardless of what units they give. I can go from volume to volume, grams to grams, moles to moles. It really doesn't matter as long as I'm aware of those equivalents. So if I have the triangle, which I have written behind me, if you don't, you can always have that slide or have a printout of that slide in front of you. I can write out those equivalents of 1 mole equals 6.02. But in this case, do I need representative particles? No, it didn't even mention formula units or atoms or molecules. Like, it didn't say anything like that. So I need to be able to say, okay, well, I definitely don't need representative particles because the question does not mention representative particles. What if I was to do like 22.4 liters? Do I need 22.4 liters? Read the question. Does it say liters at all? No. I don't want to accidentally use the wrong thing here. It doesn't mention liters. I don't even need to worry about this. That leaves molecular weight. So molar mass, and I'll say the molar mass of one thing is equal to the molar mass of the other thing because both of them are in grams. So I'll say the molar mass of C7H8 is equal to the molar mass of TNT. I know realistically that's not the case. It's not, but for this setup and using this method, you want to do that. You want to say this is equal to this. Everything's already balanced, which is wonderful, but we have to figure out what is the molecular weight of everything. So you're not going to be given this. We have to do that. So I'll give you a minute or 2 to figure out what is the molecular mass of C7H8 using your periodic table, and then what is the molecular mass of this. All I did was put the subscript out front and multiply whatever number is given to me on that periodic table. You have to be able to do this. If I don't, I'm not gonna give it to you, so you have to be able to find those numbers and plug everything. All right, so if I start with 829 grams of toluene, that's C7H8, and it wants us to convert it into grams of TNT. So I will need the molecular weight of TNT on the top, and I need to have the molecular weight of toluene on the bottom. See, and if you want to like just write out toluene instead of C7H8, you can. I'm doing TNT because I'm lazy. C7H8. What is the molecular weight of toluene?
92.
I got 92.134, but it's different. Yeah. And then what did you get for TNT? 227.11. Yeah. Now, in this case, both of these in the balance reaction have a 1 out front. So you do not need to do this setup where you put the 1 out front. That only works if they have the exact same number. So I always want to make it a habit until I'm very comfortable with the theory. But if you are very comfortable with the theory, you don't need to incorporate it in your math, your calculator. It's good to still put it out there, especially if you're doing this as a short answer problem. But you'll get the same answer if you were to leave it like this. And I got 20435 grams of tea. Does anyone want to show me, like, want me to show option 2? You're on option 2? Okay. So option 2, 829 grams of C7H8 times, and then what I have to do is take the molecular weight and flip it upside down because I want grams on the bottom. So 1 mole. Even though this is not necessary for the calculator, you still want to get in a habit when you're doing stoichiometry to have those ratios in there. Because if I need to go from one thing to another thing, it's important. So it may be 1-to-1 ratio, so the same amount of moles equals the same amount of moles. But if I want to convert from toluene to TNT, I need to incorporate that ratio because the units have to cancel. My grams have to cancel. My moles of C7 have to cancel. My moles of TNT have to cancel, and that leaves me grams of TNT. So it's the same thing here. My grams will cancel here. That's grams of C7H8, and my moles will also cancel here. It's the same math. It's the same setups and things like that. You just got to pick what works best for you. Any questions on that? Let's do this one. I'll have y'all set this one up. Right now, I want you to write it all out, write out the equation based on what they give you, and balance it. Let's do step 1. What does iron oxide look like? Like, what is the formula for iron oxide? If you can't do it on top of your head, that's fine. What does iron 3 mean? That's the charge.
Yeah,
What is the charge of oxygen?
negative.
So you have to crisscross because they're not the same number. So that's Fe2O3. So you have to have that correct or you can do anything else. What's hydrogen gas? And then iron. Yeah, Fe. If it just says iron by itself or anything that's a metal by itself, it's just a metal plus H2O. Let's balance it. All right. So 2 and 1. 3 and 1. 2 and 2. What should I do first? Yes, even though it is a pure metal, that's an easy start, is put a 2 front, okay? What about, what next? I want my oxygen to be 3, so in order for that to happen, I have to put a 3 out front, which then converts my oxygen to 3 and my H to 6. What next? 3 in front of the hydrogen. So, are you capable of doing this? This is going to require a review of 1.7 if you're not, and being able to, if I was to give you that ionic compound, break it up and you'll be able to set it up. If I give you the balance, or if I give you the reaction chemical balance, that's just, are you going to be able to do it? So that's going to be the first step for these types of problems. I'm going to rewrite it. So it's up top. Now, step 2, the equivalents that are important. How many moles of iron oxide? So I want moles of iron oxide, and they give us grams of iron metal. So the two things that I need, or the equivalents that I need, is 1 mole of Fe2O3, and I can bring the number that's out front, bring it down. And then here, this would be the molar mass of Fe, and I have to bring down that coefficient. That's the only thing that we need for this dimensional analysis. All right, so now that we have that, you go ahead and set it up and solve for it. So the molar mass here is 55.845 grams. So we made them equal to each other before I erased it. All we have to do is figure out, okay, which one goes on top, which one goes in the bottom. So it's asking about moles of iron oxides. That's why it will go on top. And that way the grams of Fe will cancel on the bottom. So I got 0.895 moles of Fe. Which I'll also get that. So if you prefer the method that I just showed, where you kind of bring an arrow down of the two that matter to the problem, and then you can kind of make them equal to each other using those equivalents, you're welcome to do that. So there's plenty of different ways to kind of help yourselves get this question started. Let's start our little break, but I'm gonna direct everyone after the break. So I'm gonna pause it. That's what's gonna stay paused. Yeah. Give me a minute, and then we'll start when I'm done. So if you are online, go ahead and download other worksheet. And we're going to continue practicing on these problems after the break. Okay. But right now, so it's 12:50, we'll come back at 12:55 to continue to take your mental break. Recording in progress. All right. So once again, we'll just do examples 1 and 2, 3, and then we'll move on to practicing for the exam. What was I gonna say? Anyway, these, you have to create your balanced reaction. So this one mentions methane and oxygen. So that one tells me this is a combustion reaction. What numbers do I need to put in front of everything? Like what number do I need to put in front of here? 1, what about here? CO2? Okay, H2O? Perfect. So that's the first step, is to balance it. The next step is I'm going to read the question. It says, how many liters of oxygen? So I'll just do like a little arrow that says, liters of O2. And then it says 50 grams of methane. So I'll do here and do grams of CH4. The only two things I care about are going to be the methane and the O2. I don't really need to worry about CO2 and H2O for this problem. Using the equivalence with the mole triangle, that would be the molecular weight of CH4 equals 22.4 liters of O2. And then you have to make sure you bring down the number out front. So 50 grams of CH4, and I want the CH4 in the bottom. So 1 times the molecular weight of CH4, 16, no. Thank you, 16.04 grams. And the top, 22.4 liters of O2. And what'd you get? Yeah. And you could probably round this one to be 210 because there's 3 sig figs here, but I'm fine with this. But yeah, not so bad. Just make sure you bring the stoichiometry out front and then use the dimensional analysis. For the last one, we have to balance it. So the first thing I'm going to do is put a 2 out front here, 2 out front here, and a 3 out front here. That way I have it all nice and balanced. So it says how many moles of iron 3 chloride. We need to figure out moles. Can be made from 15 liters of chlorine gas. So using the mole triangle, we just have to create the equivalence and we can set everything up. So 15 liters of Cl2 times 2 let me see. 24. And it's very straightforward. So If you feel more comfortable kind of setting it up like this, where you kind of focus on the two conversions that matter, just make sure that you bring the number out front with it. The key to this is on under modules. So if you want to check your answers or redo this with a blank one, it's a really good practice for the exam. Any questions on that? All right. I just want to, have a conversation about the first. So exams 1, 2, and 3 have relevant questions to what we might see on the next exam. The only question from exam 1 is what I have highlighted here. So this one just talks about polyatomic ions. So I might have a question like that on our exam where I might say, okay, what is the polyatomic ion and what is the charge? Let's just go. Does anyone, and try to do this without any notes, because you're not going to be given the polyatomic table to look at. Does anyone remember what nitrate is? Yes, it is NO3. NO3 what? -1. Okay. Does anyone remember what bromate is? Okay. I'll tell you now, anything with a bro in it is going to be bromine. And it'll have oxygen. So we don't know if it's Br like O2, BrO3, BrO4. I think if it's BrO2, it's like something else, but this is BrO3 and a -1 charge. That's just going to require like reviewing before the exam. Maybe you could make, oh, do you remember the homework thing I showed y'all, the practice of polyatomic ions? If I go into Canvas and go under Achieve Homework, there's a little thing that says Practice. There's a whole polyatomic ion practice thing where you just click on a button, click on a button, click on a button. That's going to be the best way to study polyatomic ions for this exam.
The most part are your 8 bromine nitrate. Is it going to be the O3?
I think so. Like
Chlorate.
chlorate.
I think there was.
Chlorate will be. Yeah, there's like one. I forget which one, but I think chlorate will be like CrO3, things like that. Carbonate. That's also an O3. That's a CO3. Does anyone remember the charge? That's a 2-. All right. Manganese will be in the next one because it's permanganate. That's an MnO4. What is the charge? Nope, this one's a 1-. So at least guess. If you're gonna do this, don't leave it blank. Do something, guess something. So the more partial, the better. Typically the charges are gonna be between -1 and -3. So yeah, you just gotta kind of figure it out based on that. But I highly recommend going into our Canvas site. Under the module for homework, I have a practice activity for polyatomic ions. I also have a polyatomic ion quiz that needs to get done before Wednesday. All right, now exam 2, majority of this exam we touched on exam 1. Reminder, Dr. Patterson wants us to kind of keep reviewing exam 1. So I might throw in some additional exam 1 questions that you should still remember. So any of these questions that we touched on exam 1, you should be able to remember, and I be able to answer them for exam 2. But for today's purpose, let's just hit on exactly what might be covered on exam 2. So just because it's not highlighted doesn't mean I won't ask you. All right. So number 1 says, how many molecules of P2O5 are in a sample that contains 100 atoms of oxygen? So this one, if we go to the mold triangle, P2O5, what are the representative particles of P2O5? So I have the options behind me. Options are formula units, molecules, atoms, elements, ions. Is P2O5 a molecular or ionic compound? So the formula unit, or sorry, the representative particle here would be molecules. So it's asking for molecules, but unfortunately I'm starting with 100 atoms of O. If I was just to use the 6.02 number here, it would not be my final answer. It would not be completely correct because I have to go one step further here. So the equivalents that matter for this problem is first, 1 mole equals 6.02 times 10 to the 23rd molecules. I'll do MC of P2O5. That's just using the mole triangle. The center mole equals that many represented particles of P2O5. But it mentions atoms of oxygen. If I have 1 molecule of P2O5, how many atoms of oxygen? So we need to have those two equivalents, essentially. Honestly, you just need the second equivalent. But if we were to continue to review this for this upcoming exam, you probably would need both of these equivalents. So if I have 100 atoms of O, I would want to put 1 molecule of P2O5 on top and 5 atoms of O on the bottom. So 100 divided by 5, and that is C. So yes, this is straightforward from the first exam, but it does have some relevance for this exam.
Speed up time, P2O5 and then 100 atoms of oxygen. Then I just divided 5 oxygen into the 100.
I did that.
Okay.
100 divided by 5.
Okay.
All right. So this one says, which of the following has the same charge as permanganate? Do y'all remember what permanganate is? I just had it up there.
Oh, the. Two, -2.
So
Oh, no, there's -1.
So, which of the following ions has the same charge as permanganate? Does anyone remember what cyanide looks like? Cn minus. Ammonium? Charge? No worries. Plus phosphate.
PO3.
It's PO43 minus. Sulfate. Yes, so I hope this is really telling you have to review those polyatomic ions because you will not be able to answer this question correctly or many of the other ones correctly if you're not comfortable. So you've got to do what's necessary over the next several days because we're less than a week out to get comfortable with these charges and these compounds. So out of all of these, which one has the same as it's cyanide? So this one you'd be guessing if you didn't know.
Which ones did we just go over on the last problem? Because I had 2 8.
We did bromate, we did carbonate, and nitrate.
And then
Yeah.
And then.
Permanganate. All of them had oxygen.
and all of them have 4.
No, carbonate CO3, bromate is BrO3. Nitrate is NO3. It's different. So it's, I'm telling you now, use that little mini quiz because that'll get it into your brain what it is. Use it. Use it. All in the homework tab. It's under practice. But if you don't have it yet, you've got to get it. Number 14, calculate the percent by mass of oxygen in NaClO3. So reviewing that equation, I'm not going to give it to you. First, what is the molecular weight of NaClO3? And I'll tell you now, it's not going to be greater than 100%. Not. NaClO3. And then once you have that number, just let me know.
A?
No.
Oh.
What is the molecular weight? Because you can't guess if you don't have the molecular weight. Okay, so to get this one, you need to have the whole molecular weight of everything because we're focusing on just oxygen. You take 3, so all of the oxygen's mass divided by the molecular weight of the whole compound times 100. So you focus on all of the mass of that particular element divided by the total molar mass times 100. So 106 point, that number, it was in there to throw you off. It's not a percent. You have to calculate the percent of just oxygen. All right, what did you get? Awesome. Perfect. So A was correct. So if I was to ask about Na, it'd be the same concept, but you'd put in the whole mass of sodium. If it was for chlorine, same concept. And then if you add them all up, they will equal 100. So if this was a 2-element thing, and I was to say, okay, well, now what is the percent of the other thing? You just 100 minus that number. If you solve it and get it right 100% of the time, it's okay to not do it the way I do it. Like, it doesn't mean, yeah.
No, I did.
But that's just how the slides, we discussed over the slides if I was focusing on these. All right, number 15. What ion has the wrong charge? Hmm?
Could you zoom in?
Yeah. So Na is column 1. It's a +1, yeah. P4 minus, yes. Yep. P, huh? CH plus, and then it says O2 minus. So column 1 will be +1 charge, column 2 +2. If I skip to the chlorine, bromine, so they're -1. O and down are -2. The next column, the N down is -3. So which one do you think is wrong? It's A. P will be a -3 charge. Now the next 5 questions require this. So millimole has a C3H8 tank, that's propane, for her barbecue grill that has a volume of roughly 5 gallons or 20 liters. Assume that her tank is full at the standard temperature and pressure, and so she has a sample of propane gas at standard temperature and pressure with a volume of 20 liters. That's a lot, but the question doesn't really need a lot of information for this one. What is the best description of the representative particle for C3H8? What if we use the elimination method, which one it cannot be? It's not a diatomic molecule because that's something too. It can't be an atom because there's more than one compound, so it can't be A and it can't be C. So that leaves you 2 options. Is it ionic or molecular? Ionic means formula unit, molecular means molecule. Which one is it? Molecular. So this would be molecule. So it says next 5, so I'll have to keep the next ones with the parent wording. What is the molar mass of C3H8? So 3 times 12.01 plus 8 times 1.008. So 36 plus, I believe it will be C. Y'all can see?
Yeah.
So even if we have different decimal places, you're still gonna get the right answer. So it'll definitely C. Now 18 is gonna require us to use the mole triangle. How many representative particles are in this sample? So I have to go back to the question, and it says that we have 20 liters of C3H8. I want the representative particles, which we just discussed is molecule. So I want molecule of C3H8, and I want my liters of C3H8 on the bottom. So just like stoichiometry, it's the same setup, but since we're not doing a balanced reaction, I don't need that extra step. So it's just a step before that. What number am I putting in the numerator? Look at the triangle. Yes, it's asking for representative particles, which means it has to be molecules, ions, any of that. If it asks for any of that, you need that top number. What number goes in the bottom? Anything that happens here is coming straight from this triangle, one of those numbers. Let me know what that number is. I assume it's gonna be a very big number. So it can't be D. You got B?
5.3.
Oh, C? Okay, perfect. So make sure you type that into your calculator and get that answer. 20, you could do 20 times this number and equal divided by this number, or 20 and in parentheses do this. So whatever you do, make sure you get that answer. C, 5.38 times 10 to the 23rd. And then double check your setup. If you feel like you can't go straight into this, you can always do the equivalence. 6.02 times 10 to the 23rd molecules, because that is the representative particle for this compound. H8 equals 22.4 liters equals 1 mole. So you can do that whole equivalent and figure out these are the two that matter for this problem, and then you could set it up like this. But you need the mole triangle, and you need to be able to read the mole triangle to get those numbers. Because if you can't do that, it's going to throw off your answer. Number 20 says, what is the mass of this sample? So it's asking for grams. If I go back to that mole triangle, 1 mole equals 6.02 times 10 to the 23rd representative particles. So in this case, it's molecules. All right, that's all of the numbers from the mole triangle. It gives us in the problem liters. So I already know I need this number. What other number do I need if it's asking for grams? So do I need moles? Huh? Do I need the representative particle number? No. All I need is the molecular weight of the C3H8, and I need the liters. Those are the only two numbers for us to do the dimensional analysis here. So I still have to use that 20 liters for this sample, 20 liters of C3H8 times, and the top, I'm now going to put the molecular weight, 44.11 grams of C3H8 divided by 22.4 liters of C3H8. So I'm just taking in here, these numbers are coming directly from the equivalents from the triangle. So 20 times 44.11, enter, and then divided by 22.4. What'd you get? Okay. Not so bad, but if you don't know how to start it, I can see how, one, you might be losing time on the exam. We want to try to avoid us sitting and staring at a question for a while. It's one, skip it. If you can't instantly start it, skip it so you can come back to it on the exam. And two, you can kind of eliminate what makes no sense if you have that as an option. And three, when you have the time and you're able to get started, like first, start with what you're given. In this case, we have 20 liters based on the parent question, and then we're trying to get it to grams. We need the mole triangle for that. Okay. Number 22. Which of the following pairs of names is incorrect? Y'all like light on it or off it? It's not focusing. So review. The number in the Roman numerals is the charge. And number two, if there is a polyatomic ion, we don't have to do prefixes or change the name. So if it's BrO2, if it was BrO3 and it said bromite, it would be incorrect. But bromite is BrO2. Beryllium does not need to have a Roman numeral because beryllium is on column 2. It is a fixed set number. So it is not necessary. C is correct. Same as calcium carbonate. Ca, 2 plus, CO3, 2 minus. So calcium carbonate. So that is also correct. A and B. So chromium, it says chromium 3 and aluminum 3, and it has chloride and oxide. This one you definitely want to make sure and check the crisscross. So if I have, sorry, first, I think this is BE plus BR2 minus Ca2 plus CO3 2 minus, that's correct. Cr3 plus Cl. So even if I have a different amount of chlorine, I'm sorry, I do see that. This one will definitely need crisscross. So CrCl3. Y'all see how I was able to do that? All right, Al. What is the charge of Al? 3 plus. O, what's the charge of O? 2 minus, so crisscross. Al2O3. So what is the wrong answer? Wait, I messed it up. Okay. That's where I messed it up. I thought, sorry, I think what I had was in my head, I accidentally flipped these numbers. I had it as Al3O2, and that's where I went wrong. Sorry, that's BrO2 is a -1, not a 2 minus. So this one would be crisscross. This would be BeBrO2. That would be the correct version of that. I am so sorry. So this one will be C. This one's just going to require my advice, what I just did. You can't just look at it. You have to prove it wrong. So, you know, if it's something like these with just the ionics, you're just going to have to break it up and like kind of create the compound itself. And then if it's a polyatomic, you might have to guess, maybe prove the other two are absolutely correct. And then you can move on to the polyatomic. And then maybe if you just don't know what to do, guess, and you have a 50-50 shot. But if you can, put the charges and then do your best to kind of also do the crisscross with the polyatomics. That's just going to require a little practice. 23. Which of the following compounds is chromium oxide? So just like we did before, You have to assign the charge, and then if you have to crisscross, you crisscross. What do you think it is? I agree. So if it's a 3, that's going to be a CR3 plus O2 minus, which means crisscross. So it'll be CR2 O3. One more minute, so we'll do 25. What is the name for this one? It's scandium is SC, so scandium and then O. And this is ionic, so it will require the ionic naming. So if you look at B, sorry, we'll finish this one and then we'll be done. If you look at B, B is the way that we would name molecular compounds. It's not going to be correct. So what do y'all think it is? You said what? D? Yeah, I agree. So it can't be C because then it would be Se2 plus and O2 minus. So it would be SCO. So that one can't be it. Scandium oxide, because we need to know the charge. This one I wouldn't agree because we don't know the charge of it. But this one, SC, if it's 3 plus and O2 minus, that one would require the crisscross to get the SEC. So that one would be D. So we'll continue with 26 and we'll do the rest of this exam and then we'll do exam 3 next class on Monday. Are there any questions before y'all go? All right, now is the time to hunker down and get all of the formative assessments out of the way. So get your homeworks done, get your quizzes done, and then next week we can focus on reviewing exam style questions. If you need to review the worksheets, those two.